So I'm going to speed test Java Spring. So I'm considering using Java Spring to make a railway simulator, and I'd like to know how fast it is, that is the REST services, and how fast database access is, so I can think about how I'm going to structure the simulator. Here's how I'm going to do the test. For test 1, I'm going to make 10,000 model objects. Now these are just plain Java objects with a few fields, a few getters and setters. We're going to create 10,000 of these, and we're going to do CRUD operations, that's create, read, update and delete. So for test 1, we're just going to put these 10,000 objects into a HashMap. We're going to read them back, we're going to update them by changing one of the fields, and then we're going to delete them, and we're going to see how quickly that happens. For test 2, we're going to do the same thing, but we're going to do it via Java Spring. So we're going to do it with a REST call, and we're going to call Java Spring, and Spring's going to put the things in the HashMap. For test 3, we're going to do the same thing, but this time instead of using the HashMap, we use a MySQL database. And for test 4, we'll introduce microservices. So we'll put the MySQL database in one Spring microservice, and we'll call another microservice, which will then just pass the call on. We'll see how quick that is. And then finally for test 5, we'll have the microservices as they were before, but they'll discover each other with the discovery server. So once we've done all that, we'll repeat the test, but this time we'll co-locate things differently. So first we'll run everything on the local host. So this means just everything's running on one machine. Then we'll try it over a local network. So I'll put the database and the first microservice on two different machines, but we'll run it on my home network. Then I'll go over to Birmingham, University of Birmingham, and I'll run microservice A there and microservice B, the database, at my home, which is Worcester, so that's 25 miles away. Then I'll put microservice A on the Google Cloud and get it to call microservice B at my home. And then finally I'll collocate microservice A onto a server in China, and I'll have that call my home. So this is a truly sort of worldwide test. So the first thing I need to do is get MySQL installed, and then get the Spring STS tools installed in Eclipse so that I can configure Eclipse to use Java Spring. Okay, so here's the code for our local speed test. We've got a model class, which is just a simple object with 3 fields. A key, which is a primary key, and that's an integer, a model name and a model number. The model name is a string and the model number is another integer. We've got constructors, we've got an empty constructor and one that will take in the fields. We've got getters and setters for each field, and then we've got a toString method. I've got a model database, which is really just a wrapper for this HashMap. This HashMap takes the integer as a key and then the model as a value. We have got a get size method just so that we can see that things are working by checking the size, and then we've got an add, delete, update and a read model method. The add model method will just add the model we supply into the HashMap with its key. The delete will remove it. The update is update model name, that will update the name of the model with the model with that key. And the read model method will return the model, and that takes the key as a parameter there. Then for the speed test, first we're going to create some of these model objects. Now we're going to do it with 10,000 objects. We might play around with that number, but for now I'll try 10,000. We're going to create 10,000 models. We're just giving it the key from the index of the for loop that we use to create it, and then we call the model number 1, 2, 3, and the model number will be 1, 2, 3. So we're getting that from the for loop plus 1 because the for loop starts at 0. We're adding that into a My Models list. Now this is the start of the test, so we're going to record the start date. We're going to loop through our My Models list, and we're going to add each model to the database. And then we'll output a message to say that we've done it and record the time, create date. So that's when the creation of 10,000 models is complete. Then we're going to read them back again and put them in a new list, read models. And then we'll output a message to say that we've read them all back again, and we'll record the time, the read date, when the reading is complete. Then we'll go through the models and give them a new name, call them new model, and the number, and we'll loop through the database, updating each of the 10,000 models, output status message, and record the time the update was complete. And then finally we'll delete all the models by looping through our original list, using the keys to delete the models in the model database, output the message, and look at the delete date. Then we'll output the results of the test. So the create time was the create date minus the start date. The read time will be the read minus the create. The update is the update minus the read, and the delete is the delete minus the update. So let's have a look and see what result we get. So it's very fast. It's taken us 2 milliseconds to create 10,000 records, rather add 10,000 records into a database. 2 milliseconds to read them back again. 4 milliseconds to update them, and that's probably the time it took. The difference is probably because of the time it took to build this new name here. And 2 milliseconds to delete 10,000 records. I'm just going to repeat the test again with 1,000,000 records just to see how that performs. And that, I think, is a more suitable test, but I think when we're doing things over the network it will slow down, but that is an interesting result. 133 milliseconds to create, 49 to read, 335 to update, and 62 to delete. So that's how long it takes to do CRUD operations on a hash map in Java. So now we're going to do a similar thing using Spring in various different configurations. Okay, so I've taken the model class, just copied it over into a new project. So the model class is just as it is before. I've taken the model database and I've made it a Spring service. So this is just as it is before, but I've also added a get all models method just so that we can test that things are working. Then I've made a Spring REST controller, the model controller. That's got all the methods that the model database has, but they're mapped to these URL values. And then I've made a Spring speed test client. So this is going to do the same as what we were doing before in the main method. It's going to add models, read them, update them, and delete them. So that's going to do the same as before. Now these methods are calling in turn to HTTP request method, and that's communicating with the Spring server. So now we can test that this works. I'm just going to test my methods one at a time. So I'm going to create 10 models. So first we do the add model method. So I'm just going to comment out the rest of this and just run add model. So I'm going to run up the Spring server. And we can see there that the model's hash map is empty. Now I'm going to run our test client. 10 records created. If I reload this, we can see we've got 10 records in here. Model number 1, model number 2, model number 3, up to 10. So that's what we would expect. The next thing, I'm going to just check each part of this program is working. So the next thing, read models. So to test this, I can do a system out print line once I've read the models. So now if I run this, we can see we read back the 10 models to the console. The next bit is to update models. So that's going to change the model name from model number 1, model number 2, model number 3 to new model 1, 2, 3. So I'll just run that. So there's 10 records updated. I'll go back to the browser, reload, and we can see it's renamed the names of the models. And finally, the fourth step is the delete. 10 records deleted, and that is actually comparing the size of the array we originally built with the return value from getSize, which is going through to the Spring, calling size from Spring. So this should be accurate, but I'll just double check that our models are gone, and they're gone. So now we're ready to run a speed test using Spring. So for this, I think that 1,000,000 is going to be too much. So I'm going to go back to I'm just putting all the code back in so that it goes through the create, read, update and delete, the CRUD cycle, and it's going to record the dates like in the last program and tell us how long it took to do each part. Now I think 1,000,000 is too much, so I'm going to go back to 10,000 and we'll see how long it takes to do this. I don't want to be output into the console. I know that the read works, so there's no need to output the records. 10,000 records created, read, updated, and there we go. There's the result. 1791 milliseconds, so just a second and a half to create, second and a half to read, to update and delete. I'll just run it again, get a few different results, and we'll take the average as being the final result. So a bit slower there to create, but it seems to be about a second and a half for 10,000 records. Let's slow down a bit there, but obviously this is going to be dependent on what else is going on my local network, on the local host network anyway. But that's our result for 10,000 records. Now the next thing I'm going to try, we've already added the get all models method for testing that I was using in the web browser, but I'm going to try and see the difference between reading the 10,000 models one at a time and reading them all in one big list, and we'll see the difference in speed between 10,000 little reads or one big read. So I'm just going to go back to 10 models just to make sure it's working. So I'm going to add the 10 models, and I'm going to read them all back in one go. and system out print the resulting string to the console. So let's see this. Okay, so that's 10 records created, and then we've read back 10 records. We seem to have read, yeah, I'm reading back 10 records 10 times actually. It's just even simpler than that, it's just that. Okay, so now that's working, so I'll just delete all the records. Ten records deleted. Check that they're gone in the web browser. And now let's repeat the test with 10,000. We'll see how quickly it can read. Would compare the two speeds of the two read methods. Now we've got a read date and a read all date. Okay, so now we'll rerun the speed test. 10,000 created. I don't know why all records read. Okay, read all appears to be much faster. Okay, so there I'm outputting the length of the string for all records, and now read all is done in 19 milliseconds. So clearly when we're reading, it's better to do a batch read. "13 milliseconds to read 10,000 records, as opposed to 1,700 milliseconds to read 10,001 at a time. So it's much faster to do one big read. Now I'm just going to make sure that we are reading everything by putting a breakpoint after the read all method, and we'll just pause there. So we've created our records. I'm just going to do the read all in the browser. So there we can see it's working. We've got 10,000 records. So that's good. So the next obvious thing for me to do is to convert the create method to do it as a batch. Then the update and the delete method will be a suitable test for us to test lots of little messages, and the create and the read all method will be a good test for testing one big batch create and batch read. So I'll change that. Now, in order to test this, I'm going to go back to 10 records and test it in the browser. I'll actually add them and delete them afterwards and put a breakpoint in between. So I'm going to add 10 records in one go. Okay, I just had to sort out the format of the string because I'm manually formatting the string rather than parsing JSON on the client side. So now I should be ready to go with the method. So 10 records created. If I now look in our database, we've got the 10 records. So now we have a add models method which will create them all in one go, and I've run through to 10 records deleted. So, and now the records are deleted, so I'm going to run this with 10,000. I'm going to forget about adding one at a time, so I'm going to create 10,000 in a batch. I'm going to read 10,000 in a batch. I'll also read them one at a time. And then I'll update them one at a time and delete them one at a time. Obviously, if we wanted the update or delete to be faster, we could come up with some batch method to do it. So let's see how this runs. $10,000 created, 10,000 read, all records read, 10,000 updated and 10,000 deleted. So the create took 522 milliseconds. The read was really slow this time. Okay, so the create is obviously quicker, but the update was also a bit slow. I'll try again. Now, the create is using this string builder to build our string. I think that that's probably taking most of the time. So I'm going to set the start date after we've built the string that we're sending over in create. So I'm setting the start date immediately before doing the add models request rather than when the program starts up, because building this string to send over to add models is going to take some time. Right, so the actual call to Spring is a matter of milliseconds, 93 milliseconds. Reading them back is 19 milliseconds. Which is interesting because there must be some sort of string parsing going on the other side, but that's very quick. So there's our result. I'll run it a few times and take the average. Right, so the next thing I'm going to do is, at the moment our model database is just saving into a hash map as it was before. The next thing I'm going to do is save it into MySQL database. Okay, so now I'm going to create a model database table in MySQL. I've got some pre-prepared SQL to do that. So create table model. The key I'm having to call ID because key is a reserved word in SQL. We've got model name, varchar 40, model number int, and the primary key is ID. So I'll create the table. And there's our model table. Obviously it's empty at the moment. So now I'm going to modify the program to use the SQL database rather than the hash map in the model database. So I'm going to add a repository class and get the database to talk to the repository instead of the hash map. I'll mark model up as an entity and define the column names in the fields, and I'll also add the application properties to tell it where the database is. Okay, so I've converted the database to now use the repository. So database now is really just a step towards the model repository, which is a CRUD repository, and the methods get auto-wired in there. So we've got all the same methods: the get size, add model, delete, update, read, and get all. So the client should just work as before. Like before, I'm going to reduce it down to 10 records that we're going to do, and I'll go through step at a time and look in the database to see how it looks. So I'm going to first run my Spring application. Okay, so now I'm going to run through with 10 models and using the MySQL. So we have the web browser up here, MySQL down here, and the client down here. So let's run in debug mode. At the moment we have no records in the model database. If I reload there, we've got nothing in there. So now I'm just going to run and check that everything's working. So we add our models, we add 10 records. There's our 10 records, and there they are. Then we read the models. We can see in debug, we can see the models coming through. 8, 9, 10. I must have lost count. 10 records read, that's right, it's added 10 to the read models array. All models, we read them all in one, so we've got model number 1 to model number 10. Then we update them. Let's update 5. See 5 in the database and 5 with new model name. Update the others, they're all updated, and then delete. Let's delete 5. I just got 6, 7, 8, 9, 10, and delete the final 5. And we're back to the start. So now we're ready to speed test this. So let's go back to 10,000 and see what result we get. So this appears to be very slow. 10,000 records created. $10,000 records updated. The next thing we should see is 10,000 records deleted and then the result. Okay, so there you go. It took 40 seconds to create 10,000 records, and that was still creating them with just one call to JPA, but then JPA is looping through and calling SQL in a loop. Took 14 seconds to read them back. Read all took 56 milliseconds, so that's certainly fast. Update took 37 seconds to update 10,000 records, and delete 33 seconds. So I think this is what I needed to know, and that is that my software, when it's running, is not going to be using the database for the dynamic state. It will just be saving its models into the database. So that's what I wanted to find out. So now let's take it to the next stage. So the next step, I'm going to stop using the database because that's slowing things quite a bit. So I'll go back to just having my models held in a HashMap, but I'll split the whole thing into two microservices. So there'll be the one service that we're talking to via the speed test client or the web browser, and then another service will be holding the HashMap and doing the updates in there. So I'm expecting things to approximately double the time, because we're going to be doing 2 REST calls instead of 1. So I think that the communication will take twice as long, but we'll see. Okay, so I've done this now. I'm just putting some debug code in to make sure it's doing what I expect, and that is I'm putting service A add model and service B add model. So I've got 2 microservices. The first one, microservice A, is just bound to the main address, but it has a REST template, and it's got the address of microservice B, which is running on 8081, and microservice B is bound to the DB address. So service A is going to behave as it did before. Service B is bound to DB and it contains the database. So what service A's controller is just calling the REST template across to service B. So now let's check to see if it works with 10 models. So I'm going to run the first I'm going to run up the services. So that's service A running. And service B running. And now I'm going to debug the test client. So first we put our 10 models in our local list, and then I call add models. Now we should see that ran in service A and service B. So if we look at service A add model, but service A doesn't even have a database. Service B add model. So service B should be containing the models, and if we go back to our web browser, we can see that the 10 models are in there somewhere, so they must be in the database in service B because service A doesn't have a database at all. Get size, that's working. 10 records created. We then read them back. I can just debug to see that the models are being read back. So the behavior is exactly the same as before, it's just this time we're using microservices. So we read back 10 records. Read all the models, that's working as well. We've got models 1 to 10. Update the models, let's update 5 again. And go to the web browser, refresh, we can see 5 have the new model name. And let's delete. I've deleted 5 there. And 5 of them are gone. 10 records deleted. Just confirm that they've all gone. So that's that now. These results obviously are because we're debugging, but now let's run and see if using microservices makes a difference. Okay, so we've got 100 milliseconds on the create. I'm doing 10. I thought that seemed a bit quick. So 10,000 and go. Okay, so 244 milliseconds to create, 14 seconds to read, but 45 milliseconds to read all. I'm just going to review what we had before. Okay, so before we were getting in the order of 100 milliseconds for the create, 2 seconds to read. That seems to have gone up quite a lot. Something like 18 or 19 milliseconds for read all, and 1.5 seconds for the update and delete. So I'm going to run this a few times. So we've read all in 18 milliseconds. We've created quicker than we did before, and we've read all in 18 milliseconds. I am running the right thing, I hope. Well, I must be, because I've run up the Spring Boot applications. So it seems there's a bit of variability in the time that it takes to do things, but it's still pretty quick. It seems introducing a second call is certainly not making any difference on the read all. On the create, sometimes we're getting a faster result now than we did before, and that doesn't make much sense, but maybe it's just the variability in the timing that we're getting. So I think I might run a few more tests before I can draw any conclusions, but it does seem as though introducing another step, another rest step, and using microservices is not making, it's certainly not doubling the time, at least not on the read all, and the create seems to be going faster. Okay, so on to the next step. So now on to the next step. I'm going to add a Eureka discovery server as a new Spring application. I'm going to have microservice A and B connect to each other via the discovery server. This will allow load balancing, and it will also allow us to distribute an application without having to hard code the address of each one. So let's do that. I'm not expecting it to make any difference. It might make a difference on the initial call, but after that I don't think it will slow things down at all, because I don't think the discovery server is actively used after the initial discovery. So let's see what difference this may or may not make. Okay, so I've enabled the Eureka client in both Service A and Service B. To do that, in the main application I've added the annotation enable Eureka client, and I also added the Spring starter for the Eureka client. I've added a new project, the discovery server, and that is a Eureka server, and that's got enable Eureka server annotation in the main class. Then in the application properties of both Service A and Service B, I've given it the application name, which is just Service A for Service A and Service B for Service B. And then in the controller where I access Service B, I'm going to do it by the Service B name instead of localhost and port. So let's see if this works. One more step to get it to work is to add this configuration to the Eureka server's application properties, and now I should be good to go. So I'm going to run the discovery server, I'm going to run microservice A, and run microservice B. And debug the test client. I'll run it in debug. With just 10 models. So create my 10 models locally. Called add models. 10 records created. Testing the web browser. Yeah, I trust this is going to work now. I'll just go to just after the update. Make sure the names have been updated, new model, and then go past the delete and check that the names have been deleted. And not forgetting to put the model count back up to the 10,000 We run the discovery server, service A and service B. Just make sure everything's ready by testing the web browser. Seems to be taking a bit of time before it works. Because service A is saying no instance available for service B, but it does eventually work after a little while, so I suppose that's the discovery server slowing things down just while it initializes. Let's run the test client with 10,000 records. And that seems to have slowed things down, but maybe it's just a initial run. So I'll run through a number of tests and we'll take the average as normal and we'll see how that works out. Okay, so I've run 5 different tests, and the first test was not using Spring at all, and then we had Spring Web, then we had Spring Web with MySQL database, then we had microservices, and then we had microservices and a discovery server. I've run 100 tests for each, and the tests consist of a create phase, a read phase that doesn't make sense in the not Spring version because we're looping through anyway, a read all where we did one big read, update and a delete, and these are the results we've got. So not Spring. So I did this with 1 million records rather than 10,000, so you can divide these numbers by 100 if comparing to other charts. But what we can see here is there's a bit of variability. I suppose this depends on what the process is doing at the time, but this is as fast as it's going to get. This is writing and reading from a hash map directly, so that's as fast as we could ever be. So this is not really it's a point of comparison, but it's not really the purpose of the exercise. It's just the absolute bare minimum we could ever get. Spring Web, we had this, so this we can see there's not much variability in this, a little bit of variability. I guess this is based on the speed of how busy the network card in the local machine is at the time. So we can see the create, we can't see create all, and we can't see read all at all. So these batch, the create and the read all we're doing as a batch. The read, update and delete, we're doing it by looping through, so we can only see those. See a bit of variability, but not really much. Now this is the total amount of time spent on the create, read all, update and delete is less than 5 seconds for 10,000 records. Then when we put MySQL in, it slowed things down considerably. We'll see on a comparison chart later, but now we're looking at 120. We're looking at 2 minutes for each of these tests. A bit of variability again, particularly on the update, but yeah, that's with MySQL. Then with microservices, we've taken out SQL here, we're just doing microservices. We're going at 12 seconds, again not a great deal of variability. I'm just going through these charts to see whether there's variability or whether it's quite consistent, but it's all quite consistent. When we added the discovery server, I noticed that there is now variability on the first operations. It seems to be the read, the looping read cycle. We've got that's much more than the subsequent calls, and also the update looks like it's quite a bit more as well, and I think the delete is also quite a bit more. So the discovery server, I suppose that is doing load balancing. It's probably on the first loop through, it's probably getting used to the idea it's going to be busy, and then it's improving its performance. So that's quite an interesting result, and I think it's a good result. Now we'll look at the comparison between the different methods. So now we've got the different tests along the bottom. So not Spring, Spring Web, MySQL, Microservices, and Discovery. And we can see the differences here. Now, I think for my purposes, when writing a sort of simulation application, I can write off MySQL for the processing. So I'm not going to be doing any processing of state and writing it into the database. I'll just load models from a database. It's acceptable for a model to take a number of seconds to load or save, but it's not going to be acceptable to be doing this number of reads and writes in the database if it's going to take this long. So we can write off MySQL. Also, in the next chart, I'm going to write off the non-batch updates. So I think the create and the read all are batch updates, and they're the really interesting ones. But a lesson to be learned is that if you're going to use Spring, it's better to use it with one big call with 10,000 records all in that one call, rather than 10,000 little calls. And if we look at the next chart, we can see we've got not Spring, obviously very fast. This is divided down, so it's now on 10,000 records. Spring Web and Microservices, and Spring Web, Microservices, and Discovery. You can see that the microservices do slow things down. It seems to sort of almost double the time it takes. So I guess each step we're taking on the network is taking the time. So that's worth bearing in mind, that each time one service calls another service, it's going to take that unit of time to do things. So that's another useful thing to think about, that inter-service communication should be kept to a minimum. But all this is doing 10,000 records in the create and the read. It's doing it, the maximum one is 18 milliseconds, so I think it's acceptably fast. The discovery seems to slow it down ever so slightly, but not really much, and that's probably partly due to that first call. But of course the discovery means that we're going to be able to load balance, and if one service is particularly busy, as long as we don't have state in that service, then we'll be able to put another service on to help out with the load. So that's the results so far. I think we've got some interesting conclusions. The next tests I'm going to do is about colocation. So I'm going to take the Spring Web, Microservices, and Discovery and see what happens when we colocate the services onto different machines. So for the next test, I'm going to double the size of the model object. So I'm going to add some extra fields. I'll add a double field, my double, and I'll add another string, my string, and I'll add one more, another integer, my int. And I'll see if sending a more complicated object over slows things down, and if so, by how much. Okay, so I've made the model object more complicated now by adding 3 additional fields. my double, my string, and my int. I've also changed it in the test client so it adds the fields when it does the creates. So now let's check that this is working. So I'm going to run the discovery server and run service A and B. So wait for the discovery server to start. Okay, and now I'm going to debug through our test client. I'll just want to do it with 10 for testing. Add models has been called, and there we can see we have my double, my string, and another string. We're reading it. Reading all. Updating. Just updating the model name as before. And deleting. And it's all gone. So I'm going to run up again and run the test. 10,000. Just run once. Okay, it's ready to go and run the test client. 10,000 records created. Red. Okay, it seems to slow things down a bit, but let's I'll run 100 tests and see what difference that has made. Okay, so here are the results for the comparison of entity size. So we've added the extra fields, the extra string, the int and the double to the model object, and this is the difference it's made. Now it's the first chart here is quite surprising because for the read, the update and delete, we can't really see the create and the read all, but we'll look at that in the next chart. But for the read, update and delete, it's actually speeded things up, and I've got no idea why that might be, but maybe it's just because my network card was a little less busy during the second test. I don't know. I can't imagine how increasing the quantity of data can speed things up, but that appears to be what's happened. But I guess we could say that the cost of making a REST call is having more of a significant effect, and it's not making that much difference when we're doing those many small REST calls. For the batch updates, so for the create and the read all, this is a result, and this is more like what I would expect. So it's approximately doubled, not exactly. It's gone from 18 to 30 milliseconds for 10,000 records, and the read all has gone from 8.9 to 18, so that's just a bit more than doubled there. So that's the result for making the entity size bigger, or making the amount of data that we're sending in the JSON string in the REST update, in the REST calls, bigger. Okay, so I'm going to take this test, which is using Spring Web, 2 microservices and a discovery server, and the larger entity size. I'm going to take this as the baseline for the rest of this video, and now I'm going to do tests where we're going to colocate things differently. So the next test I'm going to do is over the local network. So I'm going to be running the discovery server on one machine, service A on another machine, and service B on another machine. So in the application properties of service A and B, I've added this line, Eureka client service URL default zone, and I've pointed that to the Eureka server, the machine with the Eureka server on it. So first I'll run up the Eureka server, then I'll run service A and B and check that it's working. So now I've packaged everything up into a folder, and I've got the jars for the discovery server, microservice A and microservice B, and also I've got the test client jar. So now I can move things around and do a cloud test. So here, just to test it's working, I've already checked the database is working, but I'm going to run the discovery server, then I'm going to run I'm going to run microservice A and B, and then I'm going to run the test client, which is going to loop through and do the test with 10,000 records. I'm going to try that out locally here just to check that it's working, and then I'll try it out in different configurations around the world. The first configuration I'm going to do is a local server, and then I'll try it by putting the server in China and see how long it takes the communication to work from here to China. The previous tests I was doing were using wireless network. This time I'm going to only use a wired network. So now on to the final results of the tests. So first we did the 6 different architecture tests. There was not using Spring, where we were just putting 10,000 objects straight into a HashMap. Then using Spring, where we were calling the web service to put things into the HashMap on the server side. Then we had Spring, JPA and MySQL, so we were doing the same thing as with Spring, but we were putting the objects into a MySQL database. We had the Spring Web and microservices, so we're not using the database now, but we are getting one service to talk to another and put the things in HashMap via a step on the Spring microservices. Then we added the discovery server, and then we doubled the size of the entity. And these are the results. Not Spring, unsurprisingly, is very, very fast, and it doesn't even show up on this chart. Using Spring Web, this is the results. We've got some, it quite low values there. This is quite fast, but we have the 5 different operations: create, read all, update and delete. The create and the read all are done as batches, and they're not even showing up on here, but the read, update and delete is where we're looping through 10,000 times and calling the Spring service 10,000 times. That is taking a bit of time for the non-batch operations. When we introduced the SQL database, things slowed down quite significantly. We didn't do the read all in this test, so that's not showing up there. But the MySQL database has slowed things down quite significantly. When we add microservices, so now we're just doing a step from one microservice to another, it appears to sort of double the time that it takes. Adding the discovery server made a bit of difference, but not really much, and the surprise result is that doubling the size of the data by making the object that we were passing twice as big seemed to speed things up a bit, and that doesn't really make sense, but I guess there was something going on my home network when this happened. Okay, so in this chart I've taken out the MySQL result because I think it's fair to conclude that MySQL will be good for saving data, but it's not going to be good to use in a processing program. So when we're updating things, we can load maybe a simulation model from a database and save it after, but when we're running through the simulation, we don't want to be using the database in the loop. So I've taken the MySQL out, and now we've just got the 5 different techniques, and we can see here that the batch operations, the create and the read all, are almost invisible on these charts. The read, update and delete, where we're looping through 10,000 records, is taking a lot longer. So from this I can conclude that when we're doing things in Spring, it would be better to batch things together. It's easier to send 10,000 records in one go as a list than it is to send 10,000 individual records. So for the next chart, I've taken those non-batch operations out of the result, and we can just see the create and the read all. So this is really like a write and a read of 10,000 records. Not Spring has just started to show up on the chart there. Obviously this is like fractions of a millisecond. These are milliseconds on the y-axis. So Spring Web, we're getting very fast results. With microservices, I would say it's approximately doubling, so that makes sense. To call one Spring service takes some time, so that for then that to call another one is sort of doubling the time. Adding the discovery server seems to have slowed things down slightly, and doubling the size of the entity, that has now slowed things down. Not quite double, maybe double for the read operation. So we can conclude from that doubling the size of the entity in a batch operation will approximately double the length of time, but in non-batch operations we saw the opposite, strangely. Okay, now after the architecture test, we're going to take this as the baseline. So we're going to use Spring Web, microservices, we'll use a discovery server, and we'll use the double-sized entity. And that corresponds with this here. This is the localhost operation. So this is all running on one machine. They create 10,000 records and read 10,000 records. Now when we run it on our local network, we were using wireless, so the one Spring service was on one machine, the other Spring service was on another machine connected via wireless to the network, and the results we've got there, I've slowed things down to not an unacceptable level, but over 1 second to create 10,000 records and just under 1 second to read 10,000 records. Then I went over to Birmingham University, and I did the same again. So this time we were using a machine at home as the server, and the client was moved to Birmingham. It was then on the university's wireless network, and this is the result we got. It wasn't significantly slower, and I would blame my home wireless network for this. So the difference between running on my home wireless network and over the internet between Birmingham and Worcester is not significantly different. It's in the order of 1 second for 10,000 creates or reads. Then we kept the server at my home, and we put the client on the Google Cloud, and this is the result we got for that. So now we've taken wireless out of the equation altogether. We're using Google Cloud, so it's some server, I think reasonably local somewhere in Europe, I guess. And the create was very fast on this, and the read was in the order of 1 second. And next we moved the client over to China onto a server that we've got in China over there. This is not any sort of a cloud service. This is a server that we own in China, and this is the result we've got there. So the create 10,000 records is in the order of 2 seconds, so that's quite a bit slower than the Google Cloud, but it's approximately double what we would get on my local wireless network, which is quite an interesting result. So it's really not that bad. And the read all we're getting in the order of 3.5 seconds there, so it's maybe 3 or 4 times worse than running on the local network. But that does go to show that it doesn't make too much difference to be running things over in China, and it gives us a good idea of the sort of speeds we can expect to achieve. Okay, so that's the end of this project, and I think I've learned quite a bit with this. Importantly, I'll be doing batch operations wherever possible. I'll be using MySQL to save models, but I won't be using it in the processing of my program, and I'll be mindful of how much data I'm sending over. Obviously, I'll be avoiding there's no need, I don't think, to run things internationally from China to the UK, but that is an option, and now I've got an idea how much it will slow things down if I do something like that. So basically most of the things are sort of common sense, really, that it will be better to run things on a local network. The benefits offered by microservices are going to outweigh the in my opinion, it will outweigh the disadvantage of slowing things down a bit, because it allow us to do load balancing. So we'll be able to put extra services working if the system gets overloaded, and we won't have to duplicate the entire system. So those are the results, and it's been an interesting project for me. I hope it's been useful to you, so thanks for watching.